This is Hello Rust and I'm Matthias Endler. You are watching episode number 3 and today we will do our first code review. We will look at a small library called repo.ctl from my colleague Luca Pizzamiglio, and it's a small tool for reading FreeBSD repository files. What this tool does is not really that important for us because we will mostly focus on the Rust code itself and how to make it more idiomatic. I will give you a quick run through of the code and then we will talk about error handling, the from trade, and converting options to results and the trade-offs between both. So, with that said, let's dive right in. First, what is the goal of our library? On FreeBSD, you have a file called pkg.conf, and in there you find all the repositories where you can get packages from. So if you go to FreeBSD machine and you type man pkg.conf, you will come to the documentation of this configuration file. And I just opened it here, and you can see that there's a lot of information, and there are also down there somewhere some examples. So one example of one repository that we want to parse is this. We have a name, in this case it's just FreeBSD, and then we have a couple of fields. Not every field needs to be set or defined, but we will come to that later. In this case, you have a URL, you enable the repository, and then you have a couple other fields like the signature, the fingerprints, the mirror type, whatever that is. You can read all of this in detail on this man page, and all the fields are defined in the page. So let's go through the most important things. As I said, we have the repo name, then we have a URL for the repository, and then we have a Boolean flag to say if the repository is enabled or if it's not enabled. The default is yes. The other fields we will mostly ignore for now, simply because the repo.ctl library also only deals with a few of those fields. So to get started, you want to download the code, and you can find the code in the description. I will also add it to the video, I guess. Just download it and open it with your editor, and then you can follow along. I've opened the repository here, and there's a small readme. Let's format that real quick. Just some information with what the tool is, and not much more because it was an internal tool when it was created. Then we have a changelog with some recent changes. Then we have two main folders. One is bin and the other one is the lib, the library, which is in the repository folder. So we will mostly deal with the library, but the binary just uses this code and makes it callable from the command line. We will not get into this today, maybe in a later episode, but for today we focus on the library code only, because I think there are a few things that we can improve here, and I will go through the code now one by one and we look at what we can do. So apart from all of those includes, we have a couple external crates that we use. One is UCL, which is a crate for the universal configuration language, and that is a FreeBSD thing for. Actually, you can use it for everything. It's completely separate from FreeBSD, but it's used in FreeBSD quite often for reading those configuration files. So Luca's library uses UCL to do some of the heavy lifting. Okay, so the first thing I always try to do is build the library and see if it runs. So I say cargo build, and I get an error around the libucl sys library, and these are system bindings to libucl, which is some dependency. Let's not go into details, but it tries to call autogen, and autogen is not installed. Autogen is a tool like for building code like make, and you need to explicitly install it in macOS. So you can do that, say brew install automake and autoconf. Okay, so let's try again. Nice. We got our first running project. Now we got one warning, but it's not that bad. At least we have something that we can build upon. And thankfully, Luca also provided a list of tests, and we can also run those tests. Let's see, cargo test. We can see that the tests pass, and that's a very, very good baseline for further improvement. Now we know that everything works. So let's look into what we can do. The first thing I would do is adding the dependencies to the Readme so that the next person knows what to do. So let's do that real quick. We add a new section. We call it dependencies, and we say auto tools. That's just an example. Just put in everything that is needed to get your project running into the Readme. Okay, so let's focus on the Rust code. The first thing that jumps out is that we use an extern crate inside of our module file. While you can do that, it's usually more idiomatic to put that at the top level of your project so that it's easily noticeable what you do. So I will remove this and I move it on the top of my project, or at the top of the library itself. And then I still need to use the library in my module that I want to use. So I say use UCL, and usually I place the external dependencies below the standard dependencies, but it's just a personal style. Okay, so after that, let's look at the code. We have a repo struct here, and you can see that we already derived debug and partial equal, which is quite nice, so that we can compare repositories. We have 3 fields right now. We have a name of the repository, the URL of the repository, and this Boolean flag enabled that I told you about. So one thing that I usually try to avoid is making stringy typed APIs. In this case, we have a field called URL, but it's in fact a string, and that could bite us. For example, if we create a new repository, let's just write something down real quick here. I say let r equals repo : new, and I give it 3 fields. Let's say foo, bar, and true. Well, that would be, in this definition of repo, a valid repo type. But the problem is that bar is of course not a URL. Bar is a string. So we have some state which is incorrect, but it's representable. And usually one of the idioms in Rust is to make incorrect state unrepresentable. So instead of doing this, maybe we want to have some kind of URL, so that we can have some, I don't know. I guess we will come to that in a second. Here we have a repo implementation. We have one new function, Everything is pretty straightforward. Then we already have a display method for our repository where we use our formatter and we return a result. And yeah, also quite handy, we have a function called line trim, which might not necessarily need to be here in this code base or in this file, because it is kind of general to trim lines based on comments and white spaces, but okay. Then we have some more helper methods to get a section name. Yeah, we have one method to parse a full repository string. Then we have a method to parse multiple file names from a file, so multiple repositories, and we also kind of merged them together here. We have an implementation to get a repository from a string. We have a method to merge repositories, and then we have a number of tests to test various conditions. And yeah, so that's what we are dealing with right now. And as I said, I guess the first thing we can try is, instead of using a string for our URL, we use an actual URL type. I would look for crates in this case. So on crates.io, if I type URL, I usually get a few very canonical libraries, like URL in this case, with a lot of users and a lot of downloads. There are probably some more, but yeah, let's not overthink it right now. Let's just use the URL crate. So I would add it to my project, cargo add URL. And I also have to use it, so I include it in my library. Actually, this might go away in the future, so you don't need to write extern crate anymore. If you're watching this in a later point in time, then yeah, maybe you don't even need to do that anymore. But in this case, we say use URL. And I guess now we need to look at the documentation of URL and see what methods it provides. So from the docs, I see that we have a URL parse method, and that returns a result. I can see that from this, which is a comparison with an error. So we say use URL, and I guess it doesn't harm if we go straight to the URL struct here and use that. And then we replace our URL type with URL. And one of the things that I like to do in Rust is let me be guided by the compiler. So I will simply compile this library now and then fix all the places where I have to replace a string with this URL parse thing. So this is going to take a while. So here the compiler is complaining. You can see that in line number 20 we use a string, where instead we want to use some kind of URL. But honestly, the URL parameter is optional according to the documentation. And in this case, there is no real base URL that we can provide. So instead of providing some kind of empty value, why not just use an optional value here? So I would replace string : new with none. And on top, I define URL as option of URL. Now that's a bit better, because we have one less case where we have a state which is in fact not representable and incorrect, and we just make it go away. Now we come to the first place where we need to deal with errors. You can see that in our code in line 79 we use url_object.asString because this is some kind of UCL type. The problem is that we now have an option of a URL in our repository struct. So to mitigate that, we kind of need to do some more parsing and error handling. Let's say we get a URL back in this case, then we can parse it here, and we can say URL : parse and the URL. But of course this is not going to work because we expect first a string slice for parsing, which is easy to fix. But then we expect an option, but we get a result type. Now, in order to pass the error to the caller, we just use the question mark operator, which is still not going to use because we don't really have proper error handling. But we can already wrap the result into an option type with some. And when we now try to compile, we need to deal with error handling. We get the message convert from parse error not implemented for option none error. And that's because we return an optional repository here. But in this case, I think an option is not a good choice. I guess a better choice is to use a result, because parsing can go wrong, UCL crate handling can go wrong, and maybe some other things. And an option is just not explicit enough here. In an option we just get some repository or none. But in terms of result, we get either an okay object, or we get an error. And the error maybe tells us a bit more about what went wrong. So I will replace option with result here. And of course that changes everything. So we now need to do some more legwork in order to get our program to compile again. First we expect two arguments, a repo and an error type. And we don't really have an error type, so I would say let's just define one. And let's call it repo error. And we define it just above the repo for now. Let's say pub struct repo error. And no, actually, let's make it an enum. Error objects can be everything as long as they get wrapped as an error. So one way to do it, which is pretty simple and works quite well here, is using an enum. In our case, we need some kind of URL error. I guess we will also have a UCI error. And let's go with this for now. And I guess it's also a good idea to derive debug and partial equal, which might help us later when comparing errors in our unit tests. Okay. So we return a repo error, and we can already use it. By compiling the example again. And we have a couple other places where we use arrows now, where we can use arrows now. So in line 79 we return none. So here we need to return error, and we say repo error. What kind of error is happening here? We cannot get the section name, so let's define a name error. Maybe a section name error is better. Define it up here. Try to recompile. Let ourselves get guided by the compiler. Next thing we need to do is we need to implement from for the parse error. So there was a from implementation here somewhere for some other unrelated thing. I would just copy that and place it up here and implement from URL : parse error for repo error. Okay, so we get an E, which is a parse error from the URL crate, and we return a repo error. And we just can get rid of this and say error. Actually, let's say repo error : URL error. And we can wrap the previous error inside of our enum. And we do that by extending our URL error with an inner error. So let's give it a name E, and it's gonna be a parse error. We can define it in here. We need to import it. Yeah, let's remove the URL here. And let's go through some other code which now needs to be converted into our new option result thing. We also need to adjust the binary, which uses this library for doing its thing. If we go to the binary, I will not talk about the rest of the code in this file. I will just adjust the usage. Let's just make this option type representable, and there is no default formatter for that, so let's just use the question mark operator down here as well. Okay, and now we have our first compiling library back, and the code is already much better. Why? Because we now are more explicit with what can fail, and we show the user what to do, how to react upon error conditions. Another thing that I want to do now is to provide a display method, a display implementation for the repository. Actually, we have implemented display for repo, so why not just use it? Instead of this, we say print R, and down below we also simply print R. Sweet. But we forgot something. The tests. Cargo test. We get a lot of failures because we previously used a string type. Now we use an option of URL. So let me adjust the unit test real quick. This is rather boring, so we will skip over that. I went through the code and fixed all the places where we had option before, and now we have result, and all of our unit tests pass. So I guess that's a win. There are many more things we could talk about in this project that are not perfect, but what code is really perfect? It doesn't really matter as long as you gradually improve what you have built. In this case, we talked about error handling, we talked about result and option conversion, we talked about the from trait, and we also implemented display. I guess that's enough for today. Maybe in a future episode we will revisit this code. But for today, thanks for watching. And if you enjoyed what I showed you and you want to support the show, then please subscribe to the channel and also consider donating on Patreon. I will add a link to the pull request that I will open for the repository to the description. You can also find some show notes there, and everything else will be in the description. With that said, see you next time.